Hello everyone, my name is Neeraj Balan and I am from SYML and today we are going to discuss diagonalization. So we start with 2 by 2 matrix, that is 5, 4 and 1, 2. And then first we consider the characteristic equation, that is A minus lambda of I is equal to 0. And then with that characteristic equation is lambda square minus S1 lambda plus determinant of A is equal to 0. So first we find the S1. So how do we find S1? So yes, we find S1 with the sum of diagonalizations. So what is diagonal element? Diagonal element are 5 plus 2. So the sum of this is 5 plus 2 is 7. So S1 is 7. And then we find the determinant of A, that is in calci we get 6, that is 6. And then we put that put the S1 and determinant of A in a characteristic equation, that is lambda square minus 7 lambda plus 6 is equal to 0. And then we get then we put this in calci and we get the equation like values of lambda 1 and lambda 2, that is are the eigenvalues. And then now we have to find the eigenvectors correspond to lambda 1 and that the equation we use A minus lambda of I is equal to 0. And then what is it? A is 5, 1, 4, 2 and x1, x2 and 0. So we have to, what is lambda? Firstly lambda is equal to 1. So we have to minus the element in the diagonals. That is 5 minus 1, 1, 4, 2 minus 1 and x1, x2 and 0. So that we get 4, 1, 4, 1 and x1, x2, 0. And then we have to consider the equation, that is we have to consider R2. You can consider anything. So we consider the equation R2, that is x1 plus x2 is equal to 0. After considering, we have to put x2 or x1 is equal to t. So I am going to put x2 is equal to t. After putting x2 is equal to t, we get x1 is equal to minus 2, right? We have the value of x1 and now we have to find the x2. So how should we find x2? So then we get the x1. Firstly x1 is equal to minus t and x2 is equal to t. So we have to consider the t. What should we put the t? Then we take the value of t is equal to 1. Then we get x1 is equal to minus 1 and 1. So we have x1 right now, and then we have to find x2. So what is lambda? Lambda 2. So lambda 2 is nothing but 6. And then we have to do the same step we did in the previous. Like first we take the characteristic equation, that is A minus lambda of I, lambda 2 is equal to 0. So we have to do the same. 5, 1, 4, 2. Then x1, x2 and then 0. So what is lambda 2? Lambda 2 is 6. So we have 2, 5 minus 6, 1, 4, 5 minus 6. So after separating this, we get minus 1, 4, 1 minus 4. 1 2 equal to 0. And then we have to consider the equations we are going to consider here is R2, right? And then x1 minus 4x2 is equal to 0. We have to put something something is t. So we are going to put x2 is equal to t. x2 is equal to t. We got our x2, and after putting x2 is equal to x1 minus 4t is equal to 0, then we get x1 is equal to minus x1 is equal to 4t. And then we got our x2, that is what is x1 4t and t. After putting t is equal to 1, we get 4 and 1. So now we have to find the p. So how should we find the p? So for finding p, we use x1 and x2. So we have to put p. What is x1? x1 is equal to 4, 1. And what is x2? x2 is equal to minus 1 and 1. So we have to calculate the p inverse for that. So we put p in a calci and then inverse it. So we get 1 by 5, another 1 by 5, and then minus 1 by 5. Minus 1 by 5 and 4 by 5. So we have p right now and p inverse, and then we have to do p inverse a equal to p. So after doing that, we get what is p inverse 1 upon 5, 1 upon 5, minus 1 upon 5, and 4 upon 5. And what is a? A is 5, 4, 1, 2. And what is p? 4, 1, minus 1, 1 is equal to 0. So after putting all this, after multiplying all this, we get p inverse a p is equal to 6, 0, 0, 1. This is our final answer.